Welcome everybody. Thank you for joining us tonight. We're really glad that you're here, and we're looking forward to this evening's discussions and presenting the work we've been doing, and also the chance to answer your questions and hear what you're interested in and what you want to know about the work we've been doing too. We're hoping to tackle new ground this evening. By the end of this evening's session, we're hoping the Conservatives will still have the same leader, but So we're going to cover things from a few different perspectives this evening, which all comes under one single theme, which is how can food policy and data science work together? So we're going to look at how that might be possible, what kinds of methods can be used, and do policymakers really want or need this kind of technology, or is it just a bit of a research fetish? So we'll be hearing from myself and Anjali at Wren&Co. We'll also be hearing from Jason, Aidan and Radu from the GI Centre in the School of Science and Technology at City. And then we'll also be hearing from Ollie and Hector, who are two MSc data science graduates who we worked with. Wren&Co had the pleasure of introducing these folks to the world of food systems back in 2020, in fact. Meanwhile, they gave us a glimpse into their world of data and how they can use their technologies to help food policy making. It's been an exciting collaboration. It segued from some previous work that Anjali and I were doing with the Centre for Food Policy, which was where we first met the GI Centre. And that led on to a couple of projects, which included producing some prototypes of data visualization tools, which we then went on to test with organisations such as the Food Standards Agency and RAP. We then have also done some desk-based research, which you'll get a link to after this meeting. It's a brief framework report which dives into the deeper needs, methods and demand for data visualization and food policy making tools. So the integration of data science in the food system is inevitable. However, it's also very easy to assume that new methods are going to help people. But as we discovered with 3D TVs, just because something's cool doesn't mean actually there's a market for it. In today's world, we've got an enormous amount of data. We've got an enormous amount of data, almost too much to consume. I challenge anyone here to claim that they're fully up to date with their reading list. So the future will be about how we display and access data as much as about how we create that data. So I think I can speak for all of us here tonight that it's been a really productive and engaging partnership, and we've brought a lot of new perspectives to each other's disciplines. As we go through the talk, please add any questions in the Q&A, or also you can raise your hand at the end and we'll come to you to ask your question directly. We'd ask that you all try to remain muted throughout the meeting. You know the drill by now. So I'll hand over to Anjali now, who's going to do an introduction as well.
Hi there, everybody. So lovely to have so many of you here today. Like Gavin said, it has been a while in the making, and over the last 2.5 years, during the grueling period of COVID, we had this amazing project of researching how our food system was moving and how data around food system was accessible and also inaccessible. And also, I think during COVID, a lot of us also realized more about our food system. So we not only became consumers of our food systems, we also became educated around how our food moves, because it became such a pertinent resource. So it was such a critical time for us to learn about that system, and also for us to work towards understanding how other people consume data. Now, going on from what Gavin mentioned, is that we've done a multitude of data, going from building essentially at the beginning a toolkit that helps businesses understand a problem in relation to food policy, and then slowly moving into the role of specifically how do we get access to better data. Now, as we know, in any industry, data is very plentiful. And however, it's not always organized. Data can in many cases be very, very messy. A lot of industries, such as pharmaceutical industries, for example, their industries, because they're heavily regulated, their data is also heavily regulated and embodied into one space that the entire industry will revert back to. In the case of Bloomberg, for example, regulated industry, so the data is regulated and it's a one-stop shop. Now, to build this one-stop shop of data was not built in a day. It's taken over 40 years to get to that point where Bloomberg is a trusted resource. But essentially, how do we get to a point where our data within the food system becomes an accessible, reliable resource that is democratic for everybody? So what we've really looked at with the GI Centre in the last year or so is looking at how can we make, what does data democracy look like? It's a big question. We don't have all the answers, but we've been curious to understand how do we give everybody within our food system access to equal data in a reliable, clear and quantifiable manner. So hopefully the next 90 minutes or so gives you an insight into our minds, and hopefully you have lots of questions.
Amazing. Thanks so much, Anjali. So what we're going to do, we're going to dive into some presentations now. So we're going to go through the folks at the GI Centre, Ollie, Hector, and then Anjali and myself are presenting different areas of projects that we've worked on and the things that we've learned through that. So first up is going to be Professor Jason Dykes, who is the Professor of Visualisation at the GI Centre. And I'll hand over to you now, Jason.
Hi, thanks, Gavin. I'll just check people can hear me and see my screen. Is that all good? Great. So, as Gavin said, I'm Jason Dykes. I lead the GI Centre. And we're a group of 4 professors and 4 lecturers and 5 or 6 PhD students and some really excellent master's students from our MSc Data Science course, a couple of whom you're going to see in a moment. And we do visualisation research at City University of London. And this involves talking to and working with people who have data and challenges that they might solve with those data. So these are some of the areas that we've worked in. And you can see that we connect with people interested in all kinds of phenomena to see whether we can look at data and interact with it in new ways that enable all of us to learn something. So here are some of the partners that we've collaborated with. And well, what does all of this actually look like? Well, it's about time to give you a few examples of a system designed to help Transport for London understand and develop their cycle hire scheme by analysing and visualising data collected from the first 5 million bike journeys in London. Of a system that allowed energy modelers at E.ON to compare detailed household energy usage data with modelled scenarios and appliance configurations to understand home usage of energy. Most of our systems have many views. Here's a different view of the same kinds of data. Of a system to help ecologists understand the spatiotemporal behaviour of the gulls that they track. Seabirds in the Netherlands in this case. Of a system to help football analysts identify networks of positions taken by players during matches as they develop tactics. Of a system to help police forces identify patterns in crimes that are detected and allocate priorities and resources accordingly. Sometimes we develop sketchy prototype systems, and sometimes we then go on to develop more sophisticated functional and usable systems. And this criminal intelligence analysis system was built and then commercialized as part of a European Union funded project. And here's an example of some data visualization that we put together to help epidemiologists develop, understand, refine and use their COVID-19 models. These graphics were part of a volunteering effort in which we participated along with academics across the country in response to the pandemic. And they show how the model outputs vary in different places, at different times and under different conditions. Our visualization systems encourage modelers to interact with the data, to understand how the models work and see what they predict under different conditions. Now, we develop algorithms and we run experiments to inform and support this design work. For example, experiments that look at the efficacy of different encodings of networks for different tasks. So you can see two graphics of the same network data with two alternative encodings, one that's based on a series of connections and then another that's based on a matrix. And these two views of the network help us do different things. They support different kinds of visual inquiry. Our experimental work sometimes enables us to predict. So we can predict whether you'll be able to see the odd map out here more easily or less easily than here. And we know something about how this depends upon the complexity of the graphic and the strength of the pattern. We run these experiments with different levels of complexity of pattern and of graphic. And then we write all of this research up in academic papers. So here we developed a methodology and a design from the Transport for London collaboration. And here we developed a methodology, design and a system that were mainly influenced by the European Union funded police collaboration. And here we developed a methodology and a design in light of the EON energy modelling work. So we're well known in the discipline and pretty well connected with leading research groups around the world. And we recently published a paper in the world's oldest and first scientific journal with more than 30 colleagues in the UK who were working with us on the COVID efforts. So you'll notice some names there of some of the people that are going to be talking tonight. And we occasionally write books, some classics that are probably dating a little bit now, but also some more contemporary stuff. So to summarize, our aim is to help people understand the world by empowering them with data. And we take a very visual approach by designing highly interactive analytical graphics. And we learn about how we might achieve this by trying to do it in the real world. Ultimately, we want to show complexity in ways that are manageable and clear. We want to use visualization to embrace the richness of data and to inform our analysis. And I really want to emphasize that this is reliant upon talking to and working with people who hate data and understand data and have challenges that their data might help them solve. And this requires us to engage in conversations around data and get feedback on ideas as we develop them, which is why we like to chat to people like you at events like this one to get ideas and see whether we can work on things together. Now, we haven't heard much about food so far, but what follows will be more focused on work that we're doing on visual data analysis for food systems. And I hope you'll see how some of the ideas I've presented so far apply to the domain in which you're mainly interested. Okay, I'm going to hand over to my colleague, Dr. Aidan Slingsby.
Okay, good evening. So I'm Aidan Slingsby, I'm a lecturer, and I'm going to talk in the next few minutes about visual data science, which is about enabling partnership between computers and humans, which sounds a bit sci-fi, but it's not really. So if we imagine how we might represent the food network, this is one way we can represent it. We could imagine we have all these entities, so all these little circles are entities. An entity could be a person, it could be a farmer, it could be a wholesaler, it could be a politician, or an entity could be a policy. So it could be, they can be abstract things, or it could be a policy objective, or it could be a product. So we have a series of entities, and you can imagine these entities are linked in a graph, in a network, and each link would represent some kind of relationship. So it might be that a farmer grows a certain crops, or it might be that a policy affects a certain organization, or it might be that a policy answers a particular policy objective. So even though this is a picture, imagine this as being data. We have data on, or we could have data on entities in the food network, and we can have data on the relationships between these entities. Next slide, please. How might we map the food system? Why might we want to map the food system? Well, there's lots of examples in policymaking. So you might be interested in, if you were to change a policy, who might be affected? And if we had a data set that enumerates all the entities in the food system, and we can identify which ones are linked to certain policies, then we'd get some clues about what impacts policy changes might have, and possibly anticipate some knock-on effects. We might be interested to know what policies help meet different policy objectives. So if you had a policy objective such as increasing fresh fruit and vegetable consumption, that could be a policy objective for which policies are designed. We might also have other policy objectives such as improving farmland biodiversity. So government may set policy objectives and then policymakers try and implement policies to those. And we might be interested to know how many policies affect each policy objective. And perhaps there may be some policies that some objectives with many policies and some with fewer policies. We might be interested in how policies conflict with each other. So you might have a policy objective implementing high production standards, and you might have one about reducing food costs. And it might be that policies that affect one may have an adverse effect on the other. So if we understand the policy objectives and the policies that implement them or have effects on them, then we could understand how these relate. We might also be interested in whether policies meet the needs of a whole range of actors. So it might be that some policies benefit large farms rather than small producers. So if we had this data set with all these entities and all these relationships, we could answer these kinds of questions. But we don't have these data yet, and that's part of the research that we're doing. So at the moment, if we want to map the food system and use it in analysis, we might have a particular objective for analysis. And then it's usually a manual process that takes months. And that involves manually sifting through lots of policy documents, documents from stakeholders, trawling through web archives. And this is what policy researchers do. They spend months sifting through documents. And the drawbacks of that are that policies may change in the meantime. It's a very intensive process, time-intensive process, and there may not be enough time to capture enough of the food system to be able to adequately answer the question. And then these data collected need to be validated with a wider group of stakeholders, so we get personal perspectives on those. So not all the information will come from documents. It also involves stakeholders within the industry. And this may result in hundreds of entities and relationships. So that's a big ask, and computers can obviously help with that. So visual data science is about enabling partnership between computers and humans. So if we imagine what humans are good at identifying what's important, identifying relationships. They're good at validating things. Does this relationship seem right? Does this relationship seem right? Does this data seem correct? Humans can bring in expert knowledge and use that as context. Humans are good at weighing up alternatives and interpreting inconsistencies, and they're good at discussing with others with different points of view. So humans are very good at analysis, but humans need support when data sets become large. So computers, on the other hand, they're good at working at scale, working with large data sets. They're good at finding patterns that they're told to find. So if we can specify the type of thing we want to see, a computer can help us find that, lots and lots of data. But computers are less good at analysis and inference. But there are machine learning methods that can help. So there are methods that help computers learn what are important patterns. And there are algorithms that help extract entities and relationships. So if we had unstructured text like policy documents, we could train computers to identify entities, so people, places, policies, and infer relationships from them by analyzing the language that's used in the document. And there's also potential for computers to help identify conflicts and inconsistencies in data and identify different points of view. So interactive visualization is like the glue that helps computers and humans work together. So they can help us at all stages of data collection. So for example, sifting through all those policy documents, as I mentioned at the start, all the way to the analysis. So helping filter our thousands of entities and produce the set that we need for our decision. They can help make data more accessible and make it more accessible to a wider group of stakeholders. So it would be possible to have an enormous data set and use well-designed visualization to present the subsets necessary to do validation with other stakeholders. Data are messy, the world is messy, and visualization can help reveal the uncertainty in data. We can also interactively filter large amounts of data to make data sets interpretable. Interactive visualization can help us validate the results from our computer searches to help us validate the entities and relationships that they extract. And also, if the computer identifies patterns that are interesting, we can see those and help validate them. So at the GI Centre, we're very interested in the use of interactive visualization to help humans do better analysis by leveraging the benefits of computers. And we do research by working with academics and industry partners, by setting up MSc and PhD projects, and you'll hear about 2 MSc projects later, obtaining funding for research projects, and also obtaining funding for knowledge transfer activities between industry groups and the academic sector. So now I'll hand you over to Radu.
Hi everyone, my name is Radu and I'm also a lecturer at GI Center, and I'll be talking about how to use visual data science to get the food system that we've been talking about. So our overarching vision is to take heterogeneous data that describes the food system, such as government publications, industry reports, media stories, social media posts, and so on, and somehow automatically, using, for example, machine learning or artificial intelligence, distill it into a more structured and cohesive model of how the food system works. And a model that a computer can work with and work with effectively and store. So then we would like to make this model available, for example, as interactive data visualizations to stakeholders in the food domain, so they can explore it, study it, query it, and ultimately reason and decide with it in the ways that Aidan described. Now, each of these 3 arrows that you see here involves non-trivial research challenges, but may result in game-changing resources. And I will take the next 5 minutes to detail those. But I should clarify that this process is a relatively long-term vision, say a 5-year vision. So it's very much work in progress. Now, that being said, we have done some concrete advances along these lines, and Olli and Ekta, 2 city graduates, will talk about concrete projects along these lines after me. So the first part of the process is about taking essentially scattered bits of text and information that describe individual parts of the food system, such as a long PDF detailing a government policy or a news story or a set of tweets, and distill and aggregate them automatically, or at least with as little human effort as possible, into something structured, cohesive, that paints a picture of the food system as a whole, and that a computer can work with. An example of the thing that a computer can work with effectively is a knowledge graph, which is a list of triples of 2 things connected by a relationship like those shown here, and which Aidan kind of already introduced. Now, imagine if you could just dump a set of documents and links, web links, into a system, and the computer spat out in a matter of seconds the overview picture that those documents painted. Or even further into the future, if you want, an online resource, a resource that scours the web on its own and maintains and updates a complete and curated view of all aspects of the food system. Now, this could be a game changer, and machine learning and artificial intelligence have advanced to the point where distilling messy text intended for human consumption into something that a computer can work with is a tangible possibility. But it's by no means trivial yet. There are multiple challenges here, from deciding what raw data to include and how it should be obtained, to the algorithms that should interpret it, and also to things such as what should go into those triples. For example, what are the things in the food system, and what is the space of actions possible between those things? Because we want the space of these things to be as small as possible, but also as descriptive as possible and as familiar as possible to those working in the food system. So Ollie will talk about some of these challenges and give a sense of just how difficult it is to tackle them in a concrete research project in a few moments. Now, the second part of the process is about exposing the data once we have it in ways that people can reason about and decide with. Here at the bottom is a node link diagram, which is a quite standard way of showing information, such as those sets of triples. So this could be the foundation for viewing, exploring, and reasoning about the food system. There are other ways, but the bigger problem is that in this small example, we have 11-ish entities down here and about as many relationships between them. And the complete food system would likely involve many thousands of such entities and perhaps millions of interconnections between them. And figuring out how to show this space in a way that's helpful and not overwhelming is complicated. And again, in a few minutes, Ollie and Ekta will get a chance to show just how challenging this scale problem is. And then it's not just about how we should show the food system. It's also about, and perhaps even more so, the sort of interactions and queries that should be built into these visualizations so that people can use them, explore them, and reason with them in ways that further their goals. I hope this video will work, but it gives a glimpse of a little interactive food network we've put together. Aidan has already shown a static picture of this. So this network is already slightly larger and can't quite fit into one screen, but it's still tiny in the grand scheme of things. And you can see that it's interactive. You can drag nodes around, and if you click on it, it highlights things that it relates to. Moreover, we've played around with building into it a very specific type of interaction that you've just seen. If you click repeatedly on a node, it will inflate the things that it's connected to and that it likely upregulates or catalyzes. So you'll see in a few moments that an increase in farmers' income would likely translate into increased demand for nutrients, crop yields, and so on. And interacting with the visualization would reveal that. Now, I've used the expressor game changer a few times already. And there's an open question, like Gavin mentioned, about how such capabilities and resources can change workflows, improve decisions, and ultimately translate into a better world, and whether they do. Aidan mentioned a few examples, such as identifying and resolving policies that conflict with each other, or, as I've shown in the previous video, anticipate knock-on effects. However, it's really difficult to conjecture about all the different ways that food system stakeholders could interact with and leverage with such a resource and the impact that might have. And in fact, it complicates things because the way in which such a resource could be used directly impacts how the resource itself should be designed. How much of the food system do we want to see at any one time, for example? How do we want to query it? What sort of interactions do we need to build into it? So understanding the applications of this entire process to practice, working with stakeholders from the food domain from the very start and throughout the development process is key to the whole thing being worthwhile. And this is exactly why we are so excited to be talking to all of you here today. Again, this all is work in progress, a process that we hope we can materialize in, say, 5 years. And I'm being a little bit optimistic here. But for now, I will hand over to Ekta and Ollie, who will describe concrete projects that we've completed in the last year and that fit into this vision. Thank you.
Thank you, Radu. Hi, everyone. Previous slide, please. Hi, everyone. My name is Ekta Kanchandani, and I'm a data analyst at Vogue magazine. I worked on this project with Wren&Co and GI Centre while completing my master's in data science at City University of London last year, and would love to run you through the process of everything. My main aim with this project was to find out whether there was potential for representing, exploring, and understanding food systems using interactive data visualization techniques. Next slide, please. Next slide, please. So, what did we want to find out? We wanted to know if network visualization could play a role in food systems. I found this topic very interesting because I work in food content creation in my spare time and wanted to know more about the food industry, but I wasn't aware of food policies surrounding food systems or what any of this meant. So from a visualization perspective, understanding the data was extremely important, and I had to be able to transform a spreadsheet essentially that described part of the food system into an interactive network using visualization features. We wanted to understand whether a network could inform those involved in food policies and see what the potential of this could be. Next slide, please. So how did I do it? The first step was acquiring the data. Gavin and Anjali from Wren&Co selected food waste as an important topic with interesting policies and actors. They then converted documents from Hansard, the Food Waste Index, the Grocer, and government white papers into entities and relationships in that part of a food system. The data was recorded in a spreadsheet, which I then tidied and transformed into an interactive network viz using Flourish, which helps produce network graphics quickly and with flexibility. I explored a variety of visualization features and used symbols known as nodes, which you just saw before in Radu's viz, to represent entities, colors to represent groups, and connecting lines to show the strength of the relationships that were in the raw data. The lines had arrows to highlight the direction of the relationship, and the design was in line with all visualization theory and practice. It was very important to be able to differentiate between entities in this case, as well as to ensure that the network was readable to those without knowledge about food policies. Once the network was ready, we had to test it on a group of people with prior knowledge in the field and evaluate whether the network had any potential. We did this in the form of a small virtual focus group where I recorded responses and reactions from those involved in a series of tasks and evaluated these responses to make my conclusions. Next slide, please. So what does the network look like? This is a little video of the network. So essentially, this is a food network highlighting those involved in systems and policies using nodes grouped by color based on the type of relationship. So the little arrows that you see between all of the nodes highlight the direction of the relationship and are darker when there's multiple entities involved in that relationship. The interactive feature on this viz enables users to click on any node and drag it around the screen to group them according to particular perspectives and explore specific relationships. The color groups above as well are also interactive, and users can click on any of the groups to deselect that particular color of node, which will then allow them to explore and focus on particular types of entity. Next slide, please. So finally, we did the food network and we did the focus group, and what did we find? The quotes on the screen above are some of the responses that I recorded from food policy experts and waste experts in the field. This was a small scale study that involved only 4 experts in the field and some pretty straightforward tasks and a limited amount of training, but the results seemed quite promising. The responses helped us understand that food networks may well have the potential to play a role within food systems. We saw that there is scope for a network like this to be developed and grown and potentially help businesses find solutions, which our food waste expert made clear. Constantly updating the data behind this network is extremely important, as the food industry is constantly changing and developing itself. But I think with more work on the data and visualization design, more communication between experts and designers, and more testing, these kind of interactive food networks do have the potential to help explore food systems in useful and innovative ways and understand their complexities in a more full and possibly informed policy. Thank you very much. I'm going to hand over to my colleague Ollie now. Thank you.
Sorry, thanks, Hector. Yeah, so I'm Ollie. I'm a research engineer at HomeX, specializing in knowledge graphs and work with them. Next slide, please. So my project was to do with creating and visualizing a domain-specific knowledge graph for the food waste policy domain. So next slide, please. So as most of you will be aware, the food system is this massively complicated network with loads of different types of actors and actions and entities, but also with lots of different relationships that have direction between them as well. So some actors will act on a policy, but that policy will act on other actors. This network exists in abstract, it exists in the wild, but it's not really codified or written down anywhere. So I was looking at whether producing a knowledge graph of this network and then visualizing it would be of use to domain experts in reflecting and reasoning about their domain. And at the bottom of that slide there, you can see a couple of the classes that we found to be particularly useful in modeling this domain. And that gives you some idea of the complexity that was involved here. Next slide, please. So I built a domain-specific ontology, which is sort of like a dictionary of categorizations that are particular to food policy, and then populated that with things that met individuals that made that knowledge graph. And at the same time as that, developed a visualization of the knowledge graph. So what happened was that the visualization adjusted what was needed from the knowledge graph adjusted what was needed from the visualization. And once we had something that we were happy with, evaluated that on user study with 5 domain experts. And you can see on the right a small sample of one area of that knowledge graph that was finally built to give you an idea of some of those sort of different entities and relationships that we found. Next slide, please. So firstly, we found that knowledge graphs were pretty good for modeling the complexities of this domain. They're a very flexible and extensible format, which copes well with the complexity of food policy. The node link diagram that we produced here did seem to support participants' reasoning in a much better way than just having an off-the-shelf visualization would have done. When we were looking at the experts' use, they particularly valued being able to explore and search what was already present in the graph rather than adding and deleting nodes where they found that things were missing or shouldn't be there. And at the bottom here, you can see some of the hierarchy of categories that existed within our graph at the end. So again, you can see that really there's a lot going on even this fairly small knowledge graph. Next slide, please. So of the participants we studied, all of them said that they could see this tool being of use in their work if the underlying data was changed to be relevant for their use. The big caveat here is that this was a really small knowledge graph. We were talking about, I think, a few 100,000 links in total. And when we're talking about full-size knowledge graphs, we're talking about hundreds of billions plus. So some of the design principles may not apply when it's larger, but again, a purpose-built design will be needed. So small caveat there. And also we were limited as far as time and participant sample size went. So, so further evaluation is needed on that front. Next slide, please. So we can say fairly confidently that these visualized knowledge graphs can be of use to support domain experts in their work. And they particularly valued domain-specific functionality. So the view at the bottom here shows the actor, action, actor pathways, which were a specific view that we found through consultation with experts would be very useful. And then in study, they liked that and found that those domain-specific things were particularly useful. So really that ongoing collaboration and discussion between data experts like myself and food policy experts is key to being able to develop things that are of use. So thank you, and I'll hand back to my colleague.
I'll take over from here. Thanks, Ollie. So, and thanks everyone who's presented so far. Working with the GI Centre was fascinating, because what it brought was a visual perspective to the food system. As someone who's studied food policy, you know, we're always buried in texts, in research papers, and if I'm honest, there's often an absence of good visual representations of food systems. And here was a bunch of people who actually, they're sort of almost their first, their entry point to the food system was going to be, how do we do this visually? And so that was a really fascinating perspective that brought us into this work. And everything that you've been shown so far is a really useful, really great representation of the work that was done. And it was a fascinating way to start exploring the relationships, the activities that exist in the food system. As you heard, there were a lot of people, there were several participants in the research who said it was useful, it was interesting, etc. So what followed on from this is at the start of this year, we did a bit of desk-based research, which was looking more into sort of the validity of this work, because obviously ideas in themselves have very little value. You know, ideas only have value once they are turned into once they're executed and developed into a meaningful output. And even then, we still don't know if they're definitely a good idea. You've got to test them with people, and we need to develop them further to find out. So the great benefit of the collaboration between Wren&Co and the GI Centre is that we've got research-led product development, which is really diving into what the latest developments in data viz, data science can do. That's also focused around knowledge creation. And then on the Wren&Co side, we're looking at commercial viability. You know, has this kind of project got a long-term future? Has it, you know, can it help people in the long term? Can it be sustainable? Is it aligned with the end user's needs as well? So next slide, please. So any kind of data initiative that's going to be used by stakeholders around the world needs to be sustainable. And we're not talking about environmental sustainability this time, we're talking about economic sustainability, which is one of the 3 pillars according to the United Nations. So if we're going to create a tool for policymakers and all the other actors in the food system, it's got to have a future outside of funding cycles and grants, because any academics in the room know exactly what that's like. And any data repository needs to keep growing, because the more data that is added and harvested, the more powerful that tool will become. So we looked at understanding 3 things in this report that we did earlier this year. Is, do users actually want this? Beyond our sort of excitement around the technology, is it something that people really want? Secondly, how can we do this? And that was tackled.
Oh, sorry, Gavin, just 1 second. Just going to reshare because we can't see the screen. So, okay,
yeah,
here we are.
That's okay. I think that's okay. We can just stop there for the moment. That's a list that's coming in a moment. So yeah, secondly, how can we do this, which we've seen a bit. And thirdly, will anyone pay for this? Which is really important, because if we're going to break out of the funding cycles or needing central support, how can something like this become financially sustainable once the initial funding runs out? So what do people, do users actually want this? So what we found is that people want to view the food system as a network or an interconnected system. Great, we've got that one done. Next bullet point. We find a lot of calls in the literature that joined up data modeling will help policymakers. This comes from all corners of the food system. You hear this call. So we know that people want that too. Next bullet point. Connecting policies across different areas or silos. Again, anyone who works in food systems knows that the call for joining up silos is an eternal cry from anyone, any policymaker or any researcher. Next bullet point. We also know that policy making is messy, especially once you get into the nitty-gritty of how policies are developed. It is a messy environment, and therefore we need to be able to represent that. That's something that is very necessary, and as you probably could see from some of the diagrams shown earlier by Radu and Ollie and Ekta, that knowledge graphs do help us to at least make some sense of that messiness. Next bullet point, please. And the user interface is key, because people need to be able to use these products. They can't rely on having an Ollie or an Aidan to help them out if they want to work out what the problems are in food waste. They need to be able to access the information they need when they want it. Now, many of these points here that you're seeing on screen at the moment came from academic literature. Policymakers themselves are often very busy people, and they're not necessarily writing about what they need, they're just trying to make decisions in the moment. And also something to bear in mind is that academics are only one of the end users. They're not actually the sole one. This was any kind of large-scale data product would be used by academics, by policymakers, by businesses, and by all other actors in the food system potentially. Next slide, please. Next bullet point. And again, thank you. So we know that knowledge graphs are the solution. Next. This is a new product. There's no precedent here. It's a new market. So whilst there are examples of knowledge graphs, Netflix uses knowledge graphs to suggest that you should watch whatever next series you're going to watch. In terms of food systems modeling like this, we're really looking at a new product on the market. So it's breaking new ground in that respect. Next. We found ambivalent results in earlier research. There have been examples of policy mapping with data visualization, and it comes back with results of, yes, this is interesting, this is useful, but it's not coming back with absolute. So we need to be also prescient of that point. Next. One of the things, though, that is incredibly valuable is scenario modeling. In fact, there's a guy I spoke to earlier this year who did a Sims-like game, and basically you could model the impact of food policies on local environments. So it would tell you how the health of people would change depending on what resources were placed within the local environment. So it's fascinating. But that kind of scenario modeling is what people want, because they need to understand the impact of the changes they make within the food system. And once that kind of add-on can be built, then you really add a huge amount of value to the outputs of the product. Next. Economic impacts are also part of that. It's especially from a commercial perspective, understanding the economic impacts of policy changes is vital. Next point. Okay, there's one missing there, which is that there is some limited use of knowledge graphs like this in consultancy situations, private consultancy situations. Very large companies, we're talking some of the biggest names in the world, do use these kind of knowledge graphs to analyze new markets and things like that. So there is a limited amount of use already existing. So this document, I'll share a link to this document at the end of the meeting. You'll get it via the Eventbrite email. So watch out for that in your inbox, and it'll be along with a recording of this whole meeting. And you'll get a link to this document, and this will tell you why a sophisticated network visualization tool is needed to advance policy making, how we can build it using data visualization techniques, and what the commercial value is for businesses, NGOs, and governments. So next slide. I'm going to wrap up my bit here, but I think this quote was perfect. This was in one of the papers we found, and it says that researchers and policymakers must still actively engage in ways that bring science by design into the right decision-making pathways at the right time to ensure their use. And I think this quote speaks to both the research side of the project and the commercial side, showing that the right time and place will lead to a commercially viable product. So I'm going to hand over now to my colleague Anjali, who's going to talk a bit further about the work we've been doing.
Hi there, everybody. Thanks so much. It's so great to sort of relive what we've done in the last few years and sort of reimagine ourselves in a post-COVID world. And I think the next points I'm really going to talk about is just dovetailing from Gavin, is that we've talked about how data is messy. We've also talked about how data visualization is really impactful in clearing up this messy environment. But also, one of the most important points, can I get on the right slide, please?
Oh, that's not up. We'll have to just quickly update.
I can just.
Do you want to share yours?
Yeah, it's on there. I can just share it. If whoever's doing it can reset. I can just share. That's also fine.
Yeah, I think it just needs to be refreshed because I think it's updated since.
That's fine. Let me just share this.
Slideshow.
Oh, God. No, not with everybody here. Amazing. Okay, here we go. Finding a product user fit. Now, we've talked about, thinking about we've talked about who is going to be using the product from the lens of people within food systems. My background is consumer and food product and brand, essentially. So we're looking at who are going to be the people that are going to be able to use this product, because it's not a consumer using this product. It is essentially going to be an organization. So who is the user within the organization that's going to be using this product and the service that we've been looking at? Now, what we know so far and what everybody agrees with is that in terms of data and decision making, most sophisticated algorithms require a few basic things, whether you're scrolling through Instagram or TikTok, or whether you're trying to find the next big trend. It requires trustworthy sources in most cases, but we need relevant data. How relevant? We need relevant data that is presented in. Sorry, we need relevant data that presents information to the end, that meets the end goals of the intended user. Also, there needs to be a level of trustworthiness around decision making and the data that we use. How valid is this data, and how valid is the information that we're getting that will be able to inform strategic decisions? So as you know, before, we had a closed group, we had closed data, and we're looking within our case study. But when we move forward, what is the validity of that data? And most importantly, from a commercial perspective, is how accessible and interpretable is this data? In this situation here we are, several individuals. I am not a data science expert by any means, but we're surrounded by a team of experts who are explaining to us, but is the end user within a commercial organization or a funded organization going to have the skill set to be able to access and interpret this toolkit and the system that they adopt within their business? Now, what's really great is, as a part of our desk-based research, we went out to a large group of organizations split across different roles and responsibilities within the food system. So we spoke to revenue generating organizations, to funding organizations, to grassroots organizations as well, and asked them the same host of questions around data visualization. Now, as you can imagine, a lot of them didn't have any idea what data visualization was. A lot of them were very skilled and advanced in it. And some of them were sort of at the cusp in the middle, trying to understand it, trying to create a better relationship with data to empower their organization. And 100% of that group that we spoke to said visual learning aided their organization towards better decision making. Now, within their organization, decision making was split across multiple areas. And also the visual data and what they were using currently was obviously not as advanced as what we were recommending, but they did say it was going to help them. Now, one of the things that's really important to point out here is democratic data doesn't always support everyone. Now, I know it's quite the day to be talking about democracy in the UK, no puns intended there, but what this slide means to really say is that wealthier countries, higher revenue generating businesses have the greater power to impact consumers, to impact the planet for positive and for negative. So organizations don't always, that are on this sliding scale, their access to data is also based in the same parameters. They don't always have, their intentions might be greater, but they don't have the access to empower themselves to have better impact on their consumers the same way others might do. Now, also throughout the research, what we found is 89% of recipients felt that data transparency was important for decision making. Now, obviously, that's an obvious term. Everyone wants to know more. However, what we also found is what type of data makes decision making actually effective. Now, building a sophisticated tool that can integrate evidence-based data and can clearly display the relationship between policy areas and stakeholders would provide a value solution to businesses, NGOs, researchers, and government who seeks to understand their landscape better. Now, within Wren&Co ourselves, we work with a large variety of funded organizations. And what we've often found is that funded organizations who are critical to making decisions at EU Parliament level are funded at the end of the day. So they are stuck in two key areas. They are essentially time poor and also money poor as well as an organization. So their hands are really tied when it comes to accelerating their organization skills around new tools and new data. So we spoke to Paul Newman. He was one of our interviews that we did, and he said, we are all time poor. Data really only has value if it has been critically integrated, evaluated, designed, and delivered in accordance to your organizational goals and objectives. Now, that is a very obvious, it's a very obvious way of thinking around how the impact of this level of data is going to be. But what was interesting about Paul specifically, he works globally, he works with a high variety of leading UN organizations that really focus on global food policy. But as an organization that creates such heavy impact, at the core, they are a very, very small team, and they would have to heavily upskill their core team to be able to use such a tool. So going back to the Bloomberg example before, is Bloomberg Terminal took 40 years to get to where it is today. It was built in the 1980s and we're in 2022. So do we need to collectively as a food system work towards qualitatively enhancing, cleaning up and building a tool that will have the long-term ability to support everybody and will be constantly changed? And one of the other findings that also came up was, what technology do you already use? When we look within an organization, and I'm gathering many of you here today, how often do you log into a data analytics system? How often do you log into Google Analytics? How often do you log into Instagram Analytics? Analytics are available to us on a daily basis. On a daily basis, you might be monitoring the amount of screen time you spend on your phone. However, the users within an organization are going to be using the same technology that we use today based on the learnings that we've got. So for almost 70% of the organizations that we'd be speaking to, not only are their access to funds small, but their access to technology and their learnings around those technology are also tight. So when building the technology, it's important to build within the technology, within the remit of technology that people understand. one of the findings that we also found is that 30% of users have a willingness to pay for digital tools. Now, that might seem quite low. 30% is quite a low number. Well, if only 30% want to pay for such a tool, then is there any value in building this? But upon further research, what we also found is that there was a willingness to pay for a tool, but there was a higher willingness to pay for somebody else to analyze the data in accordance to an organization's goals. So this has led us to the understanding that data science and data visualization within food systems has an incredible essential role as we move forward into really digitizing the food system and food systems data and how we look at the system. However, there is a critical area in building analytics that support a business. So this tool necessarily doesn't have to be within an organization, but it is valuable to organizations when they don't have to build a skill set inside to support this. And one of the core findings across most businesses, whether there are, and across the tools and across the organizations that would essentially buy a tool and have the power to buy, within organizations that don't have the power to subscribe to the tool, is that the scenario is the same. It's time v skill over money. So some of the key takeaways for you. There is widespread support for visual learning to aid decision making among stakeholders. However, time is a critical resource for revenue-driven organizations, but also non-revenue-driven organizations. Visualization can help find efficiencies and also cost curves. So like I just mentioned, there's low support for having another business tool. Organizations either want a widget that can attach itself to an existing tool that they have, or they want somebody else to use the tool but deliver them the data according to their goals. Training is another cost to a business that a lot of organizations don't want to do. So again, goes back to integration and analytical services. And the most important thing that we looked at is if we can change the paradigm from time v skill over money and convert it to time knowledge equals knowledge, then we have a better outcome for people in the end. There we go.
Perfect. Thank you. Thank you so much, Anjali, and thank you everyone else as well who's presented as well. I think that was actually a really fantastic step-by-step walk through everything that we've done over the last couple of years, I think, in fact, since we first started working together. And yeah, it's been a fascinating journey. So now we've got time. If anyone has any questions at all they'd like to ask, they can raise their hand. You can ask them directly or put them in the Q&A. And yeah, if you want to ask anyone in particular, or if you want to just put something to in general, ask us all a general question and see if we have any thoughts, then now's the time to raise your hand at least. And on that note, I think it's an interesting thing. I mean, because when we came to the GI Centre originally, I got a feeling they had not really worked in food at all in terms of connecting food systems with the data science discipline. Was sort of we were very much, I think, introducing each other to the ways of our work and the ways of our discipline. And I think it's kind of interesting, Jason or Aidan or Radu. I mean, how did you find it in terms of sort of placing sort of the food system within the context of food systems within the context of your work, and how to approach these kinds of things? Do you have any thoughts around that?
I can just say something brief, I guess, to kick off, which is that I think what we know about visualization is that it is hugely expressive. It gives us real capability in terms of trying to show some of the complexities that of the world that are recorded in data. And I think we saw, a nice example with Ollie's case. And in fact, we didn't see all of what Ollie had done in his presentation, where we've got massive complexity, and we can begin to tease out some of the structure in what we're looking at. But I think one of the things that we learned is that, again, Ollie was talking about billions of connections. When you're trying to visualize billions of things, it becomes really complicated and actually unachievable. So doing some analytical processing on the data that we have to select the parts of the network that are important, or abstract parts of the network at different kind of scales and levels of detail, is a really important part of the process. And so having kind of close interconnections between analytical processing and visualization is the key. And what we know about computer science can enable us to do that in ways that I think Aidan spoke about. So I guess the complexity of the food system at all sorts of levels was something that was new to us, but also interesting, because I think that it's an area in which we can have impact potentially, and we can really apply visualization and its close links with analytics pretty effectively.
I found with a lot of these things, the bottleneck is availability of data. In GIS Center, we spend a lot of time designing ways of making data understandable. But if we don't have data, then it's little we can do. And in these projects that we talked about today, we didn't really have the data. So Gavin and Anjali created some manually, which we used in Ollie and Hector's projects. We're now looking to see whether we can use some natural language processing techniques, as I described, to help generate these data. So yeah, the bottleneck is lack of data. And even if you have data, keeping it up to date, knowing how valid it is and how correct it is, whether there's bits missing, these are the things that I think are holding us back.
Sorry, I was muted. To give people an idea of the scale, like I come again from food system side of things. And so when we did the dummy data, we did 50, I think it was 50 lines of data. Now those lines were sort of, this actor connects with this actor, they do this thing, this is the output. So there were multiple sort of columns on each line. Now I think there were 50 of those, and then we gave Ollie a literature review of somewhere in the region of 600 papers or something. So like when we think about food systems, that's like a little tiny little bit of data, and it resulted in this sort of, I think Jason calls it a Death Star of like hundreds of thousands of connections. And that's looking at like the tiniest corner of food waste out of all the things. So, the scale is something that is, it becomes vast when you put all of this information into some kind of knowledge graph or model that really does balloon in size. But then that's the power of the technology to help us make sense of something that any of us here can't hold in our own brains. So that's where the computer is far more effective. Is there anyone in the audience who's got any thoughts about how this might connect with their work? Or we've got a comment from Andrea. Would it not be helpful to build the visualization skills into food systems research students so they can continue developing these tools visualizations? If you were to connect several food systems research projects and teach those involved how to visualize their data, well, yeah, I mean, that sounds like again, maybe something for the GI Centre to consider.
I mean, you've seen two MSc projects tonight. We have 100 MSc students a year who come and do our courses, and those students need projects to do. So anybody out there who's got some ideas of MSc projects are welcome to talk to us, and we can try and match you up with a data science student. And yeah, we train students in data science who come from a variety of backgrounds. Some will come from food, some will come from finance, some will come from social science. and they do our course, they learn visualization, data science, analytics as part of that, and they go on to greater things. So that's kind of part of our role in that. And our partnership with Wren&Co and also with the Centre for Food Policy is helping us make these connections between these two disciplines.
And that was a really important point. So when we first started working together, and as mentioned, it was via the with an objective of MSc students doing some work in this area. And I think Jason or someone commented at the start that often students are actually actively trying to think of something they can represent in a visualization. And was it using the Bible as an example of something that's commonly used, especially for like natural language processing. And so there are a lot of students who are interested in looking for things they can work on. And I guess probably it's actually really good projects for students because it puts them, they're given a subject or a topic, an area they might not know much about, which is what they're going to face in a commercial perspective as well. So I think it's probably a good use case.
I gave a time frame of 5 years to kind of as a goal to perhaps get that process in place, and I think I was optimistic. So I think getting these things sorted even by researchers is not trivial at all. So in addition to having people who care about the food system and can do data science, you also need the tools to allow them to do this efficiently and at scale. And this is where some of these things that we're talking about are heading towards. I hope that answers Andrea's question.
Yeah, one of the earlier parts of our working together, because we did receive funding through the university, it's like the Higher Education Engagement Fund or something like that. So we received funding, which meant that Angela and I were able to supervise the MSc students for the entirety of their projects, and also to give them all a grounding in food systems as well from the outset to really get their heads around it. So it required quite a lot of input from our side to ensure that the students were having the support to understand what it is they're actually visualizing.
I was going to say also, I think with the next steps as well, and this is a question that I put to our team, is this was a dip in the pond. We just literally put our toes in the pond to see what we could do in a really short, limited space of time. And again, had we had, and if we do get the funding to expand, to go deeper, and also get the time to, like Radu said, to say a 5-year plan. Rome wasn't built in a day, and also technology is also changing, and consumer adoption of technology is also changing. So I just wonder, and this is a question to the GI folks and also Ollie and Hector, is if something were to get to a really strong prototype phase like this, from your expertise, and you have worked on many projects at the GI Centre that have become commercial entities, how long do you think it really takes to build something like this? Just to give our audience a realistic expectation of what this could look like, because we've only spent 18 months. Jason, Radu, Aidan? Anyone?
Yeah, so I went a little bit quiet there because it's a really hard question to answer because it depends on so many unknowns. What I would say is that the European Union project that I mentioned, that it is being commercialised, and I don't know how typical this is, but it's I think we started in 2014. We had a 5-year project that was funded across 23 partners working together on criminal intelligence analysis with 3 police forces over 5 years. And the system that came out of that, it has been, well, the IPR of the project has been bought by a commercial company, and they've been developing it since then, and it's not yet been released. And there's still there are still some there are still sort of some issues in taking that to market. I think I'll kind of put it that way. I think what I'm trying to say, without too many specifics, is that it's challenging, or certainly has been challenging in that case. So, but equally, you get companies that are putting huge amounts into R&D and developing things really quickly. So I don't know. I'm really uneasy guesstimating, but I think it depends on the amount you invest and what you're working in, and a bit of luck as well, to be honest, probably.
Okay. I think we've just had another question from Mary. Is this program only for students? Is there training for people who are working in the organizations that deal with food resources or food insecurity? Gavin, can you probably help?
I can
yeah.
Try and say something. So I guess I work for a university, and so most of our offerings are to students. We do offer courses to other courses, but I don't know much about them. But we do have a lot of students who do our master's course who are in industry, and they either go part-time and do our course whilst they're working, or they do the apprenticeship, which means that they're employed full-time, and they also do the MSc part-time. So if program meant sort of education programs, then we're mostly involved with students, but many people do the program who are working. If the program meant software, then there's lots of software out there. There's a lot of open source software. A lot of software that we teach to our students are either free or they're available with student licenses.
Okay.
Andrea asked about it depends on systems thinking, depends so strongly on understanding patterns. So unless we are thinking research projects of food systems together and explore patterns highlighted, then we might understand the drives and actors well enough. And that's part of what this is all about, is creating a method and a way of collecting data. So that could be from academic literature, automatically collecting data that helps us build that knowledge around the patterns and the behaviors and the activities, the things that have occurred. And so whether that's from a government document or an academic piece of academic literature, how can we use natural language processing? How can we use machine learning to build those models automatically and to grow the data repository that becomes the visualization? So that is kind of built into it, but it's not something we can just do. It's something that would grow over time, sort of an iterative process. From my understanding of how the sort of natural language processing works, it's very much a case of refining and refining and refining to get higher quality results, rather than creating an algorithm that just sort of can collect the correct data.
Yeah, and I will add to that by linking to Aidan's part of the talk. We are looking to create tools that empower people, essentially. So it's not that we're going to spit out the food system and that's it. We're going to spit out something that people can look at and refine and explore in terms of their own interests and draw their own conclusions. So we certainly think that people have to be an essential part of that. It's just that we would like to empower them to do things quicker and think about more data at the same time.
There's quite a nice question about links to human-computer interaction in the question, and the answer is absolutely yes. So as I mentioned, we're using visualization to help humans do work with computers, and so that's all about human-computer interaction. And in the work you saw today, we weren't focusing on that specifically, but there's absolutely a role for how we present data in ways that that people find useful and helpful and can promote discussion. So there would certainly be potential HCI MSc projects, for example, on this kind of area, and we kind of overlap. We feel that we overlap a bit with human-computer interaction, and are very interested in that.
So are there any more questions or comments or burning desires that anyone's got and they want to share at the moment?
Project ideas. Okay, great. We're going to, thanks for that, Susan. We're going to get the, we'll get the report out to you as well.
Yeah, that will come afterwards. And it is a very,
I mean, sorry, go on, Gav.
I mean, it is an exciting area. As someone who, like I say, comes from food policy, it kind of opened up a whole world of possibilities that I had never seen or experienced within the food policy realm. From my experience, a lot of the data initiatives in food policy are focused on environmental metrics, you know, huge environmental data sets, alignment of metrics, these kinds of what I consider as more quantitative kind of data, or at least kind of big data sets of, I don't know, like measuring the food system. Whereas I feel that this approaches things from a more sort of qualitative perspective, in that it's looking more at who are the people, what are they doing, how are they connected to other people, and what are those other people doing, and what is the activity that connects those people. And underneath that, you've got all the like production data, you've got the environmental data. We can connect those, we can connect all those things together, but it creates a genuine map that goes beyond like a sort of 2D, sort of just like, it goes beyond just like a basic representation that often maps of the food system currently are. You know, they're often sort of an infographic or something like that, which is a map. And it is a map, of course, but it's like comparing a 1930s OS map to sort of Google Maps. You know, they're completely different things. So that's the way that I see this sort of progresses, and why it's so enlightening as a new way of looking at how the food system exists.
I think it's also fascinating. I think one of the things that's always also been fascinating is that when you're talking about data and the food system, and if I take away data science aspect of it, food is inherently personal. So everybody that's sitting in this forum today has their relationship with food. And we because we know the data around how we like to eat, we know the data around where our food comes from most of the time, and we're learning around that. It also becomes a very private space, often that people don't, they want to be curious about, but they don't want to be curious about as well. So organizations have known this and also used this to their advantage about how they share data, what they share data, and how that data has been made accessible. Comparatively to other industries, data is available and really well analyzed and in a really beautiful fashion, but no one really cares because it doesn't really affect their day-to-day, but this affects everyone's day-to-day. So making this information accessible, understandable, and accurately is actually a very powerful way and a very powerful tool that will hopefully empower a lot of people. Yeah.
Jason,
if you have any questions that you were burning to ask right now, but you don't want to ask them right now, you can also just email us later. I know that's also fine, and we will make sure that if Gavin and I aren't the right person, we'll connect you to the wider team to get those answered and for you to explore further as well.
Brilliant. And what we'll do, so we'll start to wrap up here. Was there anyone else from the panel that wanted to add anything? No, we're all good. We're all data visualizationed out. So so after this meeting, so thanks to everyone who's joined us. Well, after this meeting, you're going to get an email. In that email, you'll find a link to the PDF reports download. You'll also find a link to the YouTube recording of this meeting. So obviously feel free to share those with your colleagues and people you work with and anyone else you know that works in food systems. And equally, just hit reply if there's anything you want to know, if you want to get in touch with anyone, or you want to hear more about anything you've seen this evening, then just hit reply and we can make sure you get connected with whoever you want to speak to. Yeah, and we're here, so if you want to have a chat about anything, just get in touch. So I think with that, we'll wrap up and let you get back to your sofas or dining tables or wherever you're going to next. So thanks to all of the panel who have presented all of their work and hopefully made this area of work a bit more explicit to those who joined. And thanks to everyone else for joining us on a Tuesday evening and giving up some of your evening to hear about the exciting work we've been doing. So appreciate everyone's time, and yeah, thanks so much for joining us, and we'll be in touch. So thanks much. Thanks a lot, everyone. Take care and have a good evening.
Thank you.